when I'm a mobile device, I'm leaving the home network. Okay, look at this here in this slide. In this slide, you can see that I'm connecting to a base station, for example, using a cell phone, and this connection is moved toward MME, and then you can see there is a connection between MME and HSS service. And according to the information, then I can move the connection toward GW or PGW. Here, we can look for this device, for this connection. We can look it as a control operation, or we can look at it as a data operation. What does it mean? In control plan, we just control everything. For example, when I said that when I'm trying to make a phone call, firstly, my company should check my balance. For example, okay, his balance is over, he cannot make a connection. This is something happens in control plan. My connection is redirected toward MME and then HSS service. And in HSS service, they said that okay, this call should be blocked. This happened in control plan. But in data plan, we are looking for a path to our destination to send information. We should create a tunnel between source and destination. And at that time, creating that tunnel is not easy. Please be clear about this. Please note that creating that tunnel between the source and destination over the backbone of LTE is not easy. Why? Because my user is a mobile user. He can move, he can go from one cells into another one. So you have to create a tunnel while you are aware about the mobility . So when we talk about router only in the router, no. Please look at, please be careful, Naima. Nothing happens in these gateways. All of the control process have been done in MME and HSS servers. Those servers control everything. And after that, they send information to SGW or PGW, to S or P gateways. Okay. Here, those servers should decide about the actions that we should do against a packet. Okay, look at this slide, slide 45. This is something interesting happens has been shown in this slide. This is my cell phone in the left side, which is connected to a base station or node B. Okay, look at the stack protocol of these two devices, my cell phone and an node B. In my cell phone, I can see the application transport IP. I can see top three layers of TCP/IP protocol, and there are some other layers at the bottom of this stack. We can see some other layers, and at the same time we can see similar layers in base station. Look at this one here in my cell phone. Under the IP layer, you can see the link layer and physical layer. A link layer with 3 sublayers and physical layer. Again, in base station, we can see similar layers and sublayers, and an IP layer here. You can compare this protocol stack with a protocol stack in a router, for example. Please look on chapter 1 slides. At the end of chapter 1, there is a figure about the layers, different layers in different network devices. For example, in a switch, in a router, you can look for that slide and compare it with this one. So here we can say that the base station is something similar to a router, but when we talk about a router, this router works over a wired network, but this base station is placed under the edge of a network, an edge between a wired word and a wireless word. So you can see here that when the BTS is connected to the wireless side, it has to use a wireless MAC, a MAC for wireless technology, for LTE technology. And in MAC of LTE technology has 3 different sublayers. The upper one is packet data convergence. This sublayer is responsible for encapsulating the IP packets into a frame that should be sent over the wireless one. Creating that frame is not easy. Please pay attention to this. Creating that packet, data frame is not easy. Why? It's not an easy operation, because we have to be care about lots of So sending information over this link, over a wireless link inside a city with different obstacles, different buildings, tall buildings, towers, trees, different size, different vehicles, bicycles, bikes, people. Okay, there are several types of obstacles in a city. And we have to prepare a wireless connection over that complex system. A city is the complex system. It's not easy at all. So we have a very specific and expert scientist to create that radio links between me and the base station. This is one of the main differences between different generations of cell phones. How I should create and manage those radio links. I should control it. For example, when I'm talking about a 3G network and a 4G network, their main difference is in radio link. And even when I'm talking about a 5G technology, the lower sublayer is medium access, is something like to medium access control or MAC layer. This sublayer is responsible for transmitting information between the cell phone, for example, and the base station. Okay, medium access control. How my cell phone can access to the medium, to medium for connecting, for sending or receiving information from base station. Okay. But maybe someone says that, okay, in Wi-Fi we have the channel. Okay, that's true. But in Wi-Fi, if you remember, I said that, okay, in Wi-Fi, if you send information, you cannot receive information at the same time. I'm sending information and I cannot receive information at the same time. But my experience in a cell phone, in a cellular network, has something else. When I'm talking over my cell phone, at the same time I can hear the voice of other side. The voice comes from other side. So what is the difference between a wireless link in Wi-Fi and in a cell phone? In cell phone technologies, always we have, when I'm connecting to a cell phone network and I'm trying to, for example, make a phone call. Okay, I'm trying to call someone, for example, my friend. When I'm trying to access to the network to make a phone call to my colleague, to my parents, to my friends, the network will assign two different channels to me. One channel for upstream and the other for downstream. What does it mean? It means that I have two channels. So at the same time, I can send information over the upstream channel. My voice, for example, my voice can be sent over the upstream channel, and at the same time, I can receive information or the sound of other side from the downlink channel or downstream channel. When we maybe someone you see that, okay, we are a TDLT, a 4G TDLT technology in or network, or FDM technology, or OFDM, or something like that. Maybe someone. Those terms refers to the structure of how that company is shared, the air resources, the channel resources between different users. We talked about FDM and TDM in the last lectures, so I'm omitted to talk about them again. But maybe you say that, okay, what is OFDM? OFDM, or orthogonal frequency division multiplexing, the technology that in this technology I'm using orthogonal channels. What is an orthogonal channels? Do you remember CDMA technology? We talked about it in the last week, I think. And I said that, okay, when I'm using CDMA technology, I can assign a code, a unique code to each user, and the user, when the user tries to send information to over the network, it should times his information with that code, that unique code, and then send over the network. And we said that code is something interesting. Why? Because those codes are orthogonal comparing to them. And I compare them to them, to each other. Those codes are orthogonal. And here, we can use a similar technology, an orthogonal technology, to send information without any interference. And for upstream use, we can use FDM or TDM technologies. When I'm trying to make a phone call over a 5G, over a 4G technology, my mobile device, the base station, can assign some frequency bands. They will assign some frequency band for me. But that is interesting. Those frequency or time slots are not scheduled. There is no standard scheduling techniques to assign the bandwidth between those different frequencies. But we can say if I use LTE technology, up to 100 megabit per second can be received to each of the devices in the network inside the cell. Okay, and here you can see the other side of the cellular technology. We talked about this part, the wireless access network, and now in wireless access network, after that I should send information toward the core to make a decision. And now you can see that when we are going toward a wired network, the protocol stack of the devices inside the wired network is something else. To control the full of this information, I can make a tunnel. make a tunnel toward the destination. For example, encapsulating datagram into GPRS tunneling protocol, and then sending datagrams toward the S gateway or P gateway. We can use this tunneling technology. However, when I'm using a tunneling technology, it's something hard to change the endpoints of the tunnel. After setting the tunnel, I cannot change the destination easily. Okay. How a user is connected to an LTE network? When a user tries to connect to a wireless network, we call it association. So the question is this: how can I associate with with a 4G base station? It has 4 steps. First step is that the base station broadcasts some signals every 5 milliseconds over the whole frequencies. Okay. These broadcast messages are something like to beacon frames in Wi-Fi. Okay. My cell phone, my mobile phone, search for that uh, broadcast signals comes from base station. Search for them and find it tries to find some empty signals over the frequency range of that network. So in this second step, the mobile phone should look for the broadcast message comes from the base station and find the bandwidth, channel bandwidth, the configuration, and something like that. Information, totally information. Some information comes from the base station. After that, my cell phone should look for should look within those information to find the best solution. After defining right information, then my mobile phone can try to associate it with the BS. And maybe sometimes after this, maybe we need some more other operations, for example, for authentication, for establishing the state, or setting the data panel, or something like that. Okay, maybe we need some other we need to do some other operations here. One of the main specification of the LT is the sleep mode of we talked about sleep mode in Wi-Fi when we talked about Wi-Fi or Bluetooth in the past lectures, and we said that because my device uses a battery to these jobs, these tasks, so I should care about the level of that battery. And as I said, in Bluetooth and Wi-Fi, to save the battery, we need to use a sleep mode to conserve the battery, save the battery. We have two different types of sleep in cell phones. The first one is light sleep. In this sleeping type, my device should be off or should be inactive for 100 milliseconds. After that, it will wake up and search for the information. So my device can sleep for 100 milliseconds. The second sleep strategy is deep sleep. In deep sleep, instead of in deep sleep, my device will go to sleep for 5 to 10 seconds. That is great. 5 to 10 seconds, my device is off. So it can save its power But when we talk about a deepest sleep, okay, so we can use sleep modes to save the battery of the cell phone. As we talked in the past slides, the backbone of today's cellular technology is fully IP. So I can say that everything, my mobile home carrier network, my everything here in these clouds, you can see that every places, every networks are only IP based, and if I want to send information from one site moving across this tree, I can use them. So in IP version 4, we use a completely IP-based networks. My backbone is fully IP-based. It means that if I want to handle my packets, instead of 1G, 2G, 3G, my phone card or my data connection should be handled completely in a different place. But here in 4G, everything is on IP. Everything. And we talked about the benefits of IP and datagram networks in the past in chapter 1. Okay, this is the last slide of today's lecture. In these days, we are moving to 5G technology. But what is the difference between a 5G technology and a 4G? The primary goal is this: increasing in peak bit rate over 10 times. Okay, so we are looking for bit rate 10 times more than the 4G, more than 4G. We want to look for a network with 10 times less latency, less than version 4, and 100 times increase in traffic capacity. So in 5G, I'm looking for a very high bandwidth wireless network. Reaching these capabilities, these goals, is not easy. So to do this, we can see the scientists assign new radio channels for 5G networks, or we call it 5G NR. NR means new radio. Everything, the uplink and downlink, with new different new frequency channels without backward competitors, and we need to use the advanced technology in antenna design, for example, using MIMO or something like that. Okay, but when we talked about 5G, there is one important note. If you look on the internet, you can see that in 5G networks, we are using in 5G, we are using gigahertz frequency bandwidth signals. This means that those signals have a higher frequencies. They can send higher amount of data, but because of their high frequency, those frequency those frequencies have a large amount of energy. So they are not useful for the nature, for body lives. It's very important. That frequency ranges has lots of power and they are not good for our lives. And also, those higher frequency makes a shorter communication range. So, in contrast with 4G, 3G, 4G, 2G technologies, in 5G, we have to use picocells. It means that those cells has only maybe 10 to 100 meters radius. Oh, excuse me, diameter. The diameter of those cells is less than 100 meters. What does it mean? It means that I need to deploy too many base stations in a city. If I'm looking to install 5G, for example, deploying 5G my city, I have to deploy too many towers, too many base stations in the city. Because here, I said that in 5G we are using picocells. Okay, we have too many cells, too many picocells, small cells, so we need too many infrastructure, a dense deployment, massive deployment, which is costly. So we have to pay too many money. We have to pay a lot, big cost. You have to pay for big costs, very big costs, and at the same time, still we have some concerns. We're worried about the harms of 5G technology because the 5G technology uses microwave frequencies with very high signals with very high frequencies. For example, maybe some people talked about 60 gigahertz signals. It's very dangerous. Yes, Naima, especially in 5G. So, when we look over the trend of new emerging technologies over the world, you can see before 5G, you can see that always the USA has the flag. The USA is the leader in developing new technologies. Okay, always until 4G, but in 5G, the USA never talks about the implementation of 5G technologies. You can see that in the West, nobody looks for those technologies. There is no company who said, okay, I want to deploy this technology. But in the West, the Chinese, company always talk about 5G. For example, Huawei said, okay, let me install 5G networks in your country. But if you look closer to this technology, firstly, we should answer that how they resolve those harms, especially for cancers, for bad effects on bodies, on people, on animals, on trees. It's very important. Firstly, I think firstly we should talk about these harmful aspects of 5G technology, and then going toward those technologies, some such as 5G technologies. And now, in current days, if you search over the internet, you can see some people are looking for 6th generation of cellular networks. That is important. That is interesting. Still, we are in the first. We are standing in the first steps of 5G technology, but some people are looking for 6th generation of that technology. And the last thing in this lecture, if you look over the structure of 4G, 5G, and 6G, you can see the artificial intelligence technology, AI technology, has been used vastly in 5G and 6G, the 5th and 6th generation of cell phones. They are widely used in those networks. Why? Because, for example, in 5G, I said that, okay, I'm using picocells because I want to use signals with very high frequency signals. So they are they have two power. Those signals have two many powers, and they are at the same time their communication ranges are very short. So I'm using picocells, and the main question is this: how can I control those picocells? How can I control those picocells, especially in mobility aspects? Okay, inshallah, in the next lectures, we will talk about mobility, and we show that how we can control a user in a mobile cell phone, for example, a cell phone, or in a mobile IP environment. It's very important how we can handle those mobilities in wireless networks. Okay. Thank you for joining the class. Is there any question? Any question?